Okay, apologies in advance. I am gone again today, clearly. But here I am. I'm recording this review for you guys, right? So that's my apology. My son's sick today. So, let's all have our probability packet out. And what I'm going to do is I'm going to... I took some screenshots of some of the worksheets that you were assigned. And I know some of you haven't started this yet. So what we're going to do is we're going to just kind of go through the list. And where's my list? And I'm just going to pick out problems that are like inspired by what's on your test tomorrow. And I apologize so much that I'm not there for you guys the 2 days leading up to your summative, but I have full confidence that we'll get it done. All right, so on Worksheet 3. We haven't really talked much about, or at all, about odds. So let's talk quickly about actually all these questions. So yeah, I'm doing your homework with you, but that's okay. So if you roll a six-sided die, your sample space is 1, 2, 3, 4, 5, or 6. That you know. So the probability of rolling a 2 would be 1 out of the 6 outcomes, so 1/6. The probability of rolling a number 2 or greater, well, that would be 2 or 3 or 4 or 5 or 6, so that would be 5 out of the 6 outcomes. And then they switch it up, and now they want us to come up with what's called odds. So odds are, instead of winners out of total as a fraction, what we're going to do is we're going to say it's winners as compared to the number of losers. So a multiple of 2 for rolling a dice, a winner in that case would be 2, 4, and 6. So there's 3 winners, which means the other guys are losers, so 1, 3, and 5. So 3 to 3 are the odds of rolling a multiple of 2, but just like how fractions can reduce, odds ratios can reduce as well. And some textbooks differ on this, but I would like you guys to write the odds as a ratio with a colon in between. So rather than a fraction, because that signifies to me that odds are different than probability. So this next question that's circled, a number less than 3, the odds of rolling a number less than 3. So 1 and 2 would be considered a winner. So we have 2 winners compared to the 4 losers. And that ratio reduces to 1 to 2. All right, so I know the odds concept is a little foreign to us. We don't really think about odds too much, unless you're into gambling. Hope you're not. All right, so this set of questions here is referring to a bag of marbles. I don't think any of these were assigned to you, but I am going to tell you that number 23 would be a really fantastic question for us to look at anyways. So we have 5, 8, 2, and 7 marbles in this bag. So we have 22 marbles total. And this question says they want you to find the odds of not drawing a blue marble. So in this case, a winner would be pulling anything that's not blue. So winner, winner, winner. So that's 15, right? So 15 winners, and then a loser in this case would be a blue marble. So 15 to 7. So I might be giving you some questions tomorrow in the test where I don't really talk much about any context. So like when I look at the next side of this worksheet, I give you a probability fraction, and then I want you to compare that to the odds ratio or vice versa. And you got to be careful about the way they word these. So 23, 24, 25 are good questions for us to look at, particularly 25 and 26 actually, these two. So I'll let you have fun with 24. Let's look at 25 and 26. The probability that an event will occur is 2 out of 5 times. So what I usually do when they give me a probability ratio like this, that to me means we have 2 winners. So winner, winner. And then out of 5 total outcomes, so that means I have 3 losers. So lose, lose, lose. So 2 out of the 5 times is a winner. So now the question says, what are the odds that the event will not occur? So be careful. They want the odds that we're going to lose. So 3 times they lost compared to, remember, odds. So to winners, there were 2 winners. So going from probability to odds, especially if it's the negative version of the probability, you have to be really careful about that. So the odds that an event will occur are 7 to 4. So that means I have 7 winners, yeah, and 4 losers. So I'm going to write myself a little note. That means I have a total of, 11 events that occurred. The probability that the event will occur would be 7 times that it won or does occur. And remember, probability is written as a fraction, so 7 over the total, so 7 over 11. So make sure you're okay with going between probability and odds, and whatever I give you, you can come up with the other one. Those are kind of weird. So even though some of them are circled, and we already did 2 out of those 3, maybe go back and do a couple more for practice before your test tomorrow. All right, on this worksheet, so I'm looking at Worksheet 4. This table is interesting because it's collecting the data. So you just have to be kind of careful about how you answer these. So the difference between and or is, I think, one of the most challenging things in probability. So the probability that you select a person who earns over 30,000 and has a less than high school education. So if I look through the table here, the people who have less than high school education and earn over 30,000 are these people right here. So 2 out of, and I think I did total this at some point. I swear I did, I swear. Maybe not, I don't know. 1205, I'm seeing. Alright, and of course, if any of these ratios reduce and I don't do them, I apologize. Alright, this next one, this is the one I'm worried about. Looking at data from a table. Maybe you don't want me there today. Alright, data from a table. When they say the word or, you have to be careful, because remember the or formula has some overlap because of the Venn diagram idea. These are not mutually exclusive events. So you have a high school education, or you earn less than 30,000. So what you could do is you could find all the people with high school education. Now this table in particular doesn't give you a total box, so that's kind of annoying. And then you could add it to all the people who earn over 30,000, but then you'd have to subtract off the people that you double counted. So the people that you double counted are the high school education people who earn over 30,000. So high school who earn over 30,000. Those 14 people are going to be counted twice if you do that formula. So what I'm going to do instead is I'm just going to go through this chart and I'm just going to circle things that, or box in things that I need. So high school education would be, I need you and you and you. Ding, ding, ding. I'll add those up. And then anybody else who I haven't already included who earns over 30,000. So you and you and you. So if I went through and added up all those numbers, which I think I already did, maybe. I think it's 614. So if that's not correct, I apologize, but I think it's 614 out of 1205. I don't know if that reduces. I didn't bother looking. Alright, so be careful. And versus or. 2 very, very, very different concepts. On this worksheet, we're on Worksheet 5 now. 1 is a good practice question for our summative. So what's the probability that you're going to randomly select an item with white or red on it? So we got to read what's going on here. I have 2 red shirts. I have 1 blue shirt. I have 3 shirts that have red and white stripes. It's a very specific wardrobe. And the display also shows 2 pairs of blue jeans and 1 pair of white pants and 1 pair of white shorts. So we have, let's talk about how many total items we have here. I have 2 plus 1 plus 3 plus 2 plus 1 plus 1, 2, 2, 4, 6, 10? 10 items? So when they say the probability of selecting 1 item and it has white or red on it. So red shirt, that's got red, no. These 3 shirts with red and white stripes, that counts. Blue jeans, no. And then 1 pair of white pants and 1 pair of white shorts. So 5, 6, 7 out of 10. So multiple choice question, which helps, but remember, don't be distracted by some distracting answers. Hey, Log. Got the baby here with me. Say hi, logarithm. You say hi. All right, 2 and 3 and 4 are also really good questions to look at. So that same question about the blue jeans, you're going to be very distracting to everybody. What's the probability of randomly selecting 2 items and getting a pair of blue jeans, putting them back in the display, so this is called with replacement, and then going back in and selecting a blue shirt. So we have 2 events, but we're going to multiply the probabilities together. So a pair of blue jeans, I already forgot, it was 2 blue jeans, right? Yeah, so 2 out of 10. Don't even bother reducing that. And then put it back, and then you're going to select a blue shirt, which was 1 out of 10. So we have 3 out of 100. Oh, wait, something's not right, Abruzzo. What did I do? Getting a pair of blue jeans, putting them back in the display, and then randomly selecting a blue shirt. It did something dumb. Aw, I quit. See, aren't you glad I'm not here today? What number is this? Oh my gosh. That cute child behind me distracted me. 2 times 1 is not 3. It's 2. I almost did it again. It's 2. It's 2. 2 out of 100. Which is 1 out of 50. There we go. See, maybe it's not so bad I'm gone today. Number 3. This time, we have probability of randomly selecting a complete outfit, 1 shirt and 1 bottoms. Yeah, go ahead, play with that. Yeah. On 2 picks. Now, this time, since we're going to need to wear the clothes, we are not going to replace the first item, so that's going to change our denominator. So, how many tops do we have going on here? Let's see, 2 shirts, 1 shirt, 3 shirts. So that's 6 different shirts. So 6 out of 10. And then the next time when I go to reach in and get something like shorts or pants, let's see, I got 2, 1, 1, so 4. But remember, you already took 1 item out for the top that you're going to choose for the outfit, so there's only 9. That's how I would interpret the question. They weren't real specific, but I'm assuming that's what they're going for here. So, looks like I already reduced this for myself, and it's 4/15. If for some reason you wanted to put the shirt back in the display, I don't know why you would. That would change things, of course. All right. You've lost the basketball? Where'd it go? Okay. We're on worksheet 6 now. I'm going to probably save worksheet 6. Like, okay, nothing's really due until tomorrow. So let's say I want, like, all your homework, like, just keep the whole packet together and turn in the whole packet after your test tomorrow. I don't remember what I assigned on this worksheet, but 9 and 10 are really good questions for us to look at, whether they were assigned or not, because they're like what's on your test. So we have a class of 14 students, those are total, and we're going to pick a committee of 3 students. So committee is one of our keywords for what we call a combination. So, because order doesn't matter, if I select 3 kids and I rearrange the order in which I list them off, it doesn't give me a different committee. So the easiest way to do this question is to use your calculator. So type the 14 first, and then pull up the combination feature. And then using that probability menu, you get an answer of, I know the suspense is killing you. What number is this? 364, I think. That's what it says. The other option is to use the very long combination formula, which I didn't really go over on the notes, so if you already know it, it's at the top of worksheet 6 if you want to use it, but who does want to do that? All right, class of 15 is going to elect the president, vice president, and secretary. Now, because we are assigning them roles, it never says the word assign, but that's what's happening. You're assigning them a role. That means we have a permutation. Seems real sick, doesn't it? All right, so 15 kids, and we are assigning them 1, 2, 3 different roles. So this is a 15 permutations of 3. Or the way I like to do this question is that counting principle. So president, vice president, and secretary. 15 choices for president, and then that kid can't be anything else. So now it's 14 choices for vice president, and 13 for whatever, secretary. So this comes out to 2730. It's a whole bunch of ways we can assign 3 kids to a role. Alright, so worksheet 6B, other side of that worksheet. Good question for your test. Go ahead, baby. Oh, very good. Oh, don't hurt. Just kicked a ball to my ceiling. A traveler can choose 3 airlines, from 3 airlines, 5 hotels, and 4 rental car companies. So this is a perfect counting principle question because you have 1, 2, 3 decisions to make. 3 choices, 5 choices, and 4 choices. And we're going to multiply those together. I know. All right, multiply those together and you get 60 different ways we could figure this out. Alright, so I'm still on worksheet 6B, and I wanted to determine whether you need a permutation or combination. Okay, bud. So, this is not ideal, guys. You draw 5 raffle winners from a basket of 50 names, and each person gets the same prize. So you don't really care. Hey, stop it. You don't really care. Oh, you see that. Can you not hit my smartboard, though? Since everybody gets the same prize, it doesn't matter what order you're selecting these people in. They just want to win a prize. So this is a great combination question. So for us, we're going to grab our calculator. Out of our 50 people, we're choosing a combination of 5 people to win a prize. And I never do these in my head because they're hard for me to think about. I use factorial. Ugh, it's awesome. Alright, 31. Oh boy. 2 million. Careful. 2,118,760. I think that says. I don't know. I can't even read my own writing. The point is a lot. Now, if you accidentally hit the permutation key, you'd have even more than that. So be careful. Alrighty. Number 40 is another good counting principle question. So be careful here. You're going to choose 1 appetizer, 1 entree, 2 sides, and 1 dessert. So you technically have 1 appetizer, 1 entree, 2 sides, and 1 dessert. So how many different meals could you choose? This is kind of a weird question. Because the 2 sides business actually complicates this a little more than I wanted it to be. So I'm not going to give you one that's complicated on the test. The 2 sides, they don't indicate that they have to be different. You could get 2 sides of broccoli. Broccoli's good for you. The problem is that kind of messes up our formula here. So just for simplicity's sake, if you guys don't mind, let's say that I can't choose 2 of the same sides, because that actually makes everything kind of easier. Because if you can choose 2 of the same sides, you guys don't know about this yet, but that causes problems. So when I go to choose my appetizer, I have 4 different appetizers. Then when I go to choose my entree, I have 5 different entree choices. For my sides, I have 8 sides to choose from. Now I know in my answer key, I just put another 8 here. You know what? Forget it. I don't want to mess with my answer key. Let's just call it 8. The teacher, I can do that. Alright, and then 3 desserts. So my last choice there is a dessert. So if I multiplied all these numbers together, I get 3,840 different meals I could create. So, like I said, it's more complicated than I really wanted this one to be. Don't worry about it. The one on the test is much easier than that. So, this next page is not on any of your papers, but this is, I think we need some more practice with what are called contingency tables. So this is a worksheet that you may have done in Algebra 2, and it was it was very morbid. It was about the probability of surviving the Titanic, depending on what class you were in, first class, second class, third class, or the crew. So we all watched the Titanic. We know what happened, right? So this question, here's all the data. I know it's kind of hard to read, but it says, what's the probability that you are in second class or you are alive? Yeah. Oh, look at you go. So second class, since there are some totals here, I'm just going to take the total. So here's the second class total. That's 285 people. And then how many people live? Let's see, alive, total of 710 people. But we counted these people twice. So using the OR formula, I would have to subtract 118 right there. So I don't have a calculator on me right now, but if I were to add these, subtract 118, and then throw it over 2201, that would be the another way to find the or probability on a contingency table. The other option was to just add up your alive people, or sorry, add up your second class people, and then add up the alive people that you haven't already included. So these 2 plus these 3, and you would have got this same numerator number. So the idea is, are you going to do the subtracting on your own, or are you going to use the formula to subtract? And it doesn't matter, whatever is more effective for you. Now this is careful. You're going to be careful because this one's Anne. What are you doing? What? Where did the ball go? Oh, it's in the hoop. Okay, just a moment. We're back. Crew and alive. This is not this formula. So crew and alive means you go and find the one number on the table that you need. So crew, alive, are these 212 people out of the total 2201. So if that reduces, I don't know. Now at the bottom here, let's see here, if I could. Well, if you could see it, here I'll extend the page. It says probability that you live given that you are in the 3rd class. So that's what this symbol means. It means given. So what I like to do on the given conditional questions is whatever the given part is, that's the part I highlight in my table or box in or something. So you are only allowed to look at data from the 3rd class information. These are the only numbers you can use for your probability. So probability that you are alive and given that you're from the 3rd class is 178 out of only the total 3rd class, so 706. Now this fraction does reduce. I have no idea what to, but whatever. You just math that or enter that on your calculator. All right, again, not on your worksheet. This is just for fun. So, baseball, Derek Jeter. All right.
I just bounced it in this chart.
Yeah. There's no totals on this chart, so that's kind of irritating. But it's some more practice with conditional probability. So given that the hit happened in the 2007 season, it means that you're only allowed to look at information right here. So first thing I noticed, since I don't have total, I should probably total these up, right? Oh, for Pete's sake. I have a calculator, guys. So whatever this number is, I'm going to need it. And then the question is, what's the probability that he hit a home run? So boom, 12 home runs out of whatever this total, whatever that number is, goes down in the denominator. So you see what I mean by the conditional probability is, like if it's in a chart, what we call a contingency table, it's awesome because you can just highlight the row or the column that you're focusing on. So like on this one, the hit was a double given that it happened during his career. So this time you're only allowed to look at the data from his career. Oops. And then, of course, we'd have to figure out the total here. So given... Oh my gosh, you're going to break my room. Alright, given that the hit happened in his career, we're only looking here. I'm sure I would have totally added those up together. And the hit was a double, so I'm looking at that number right there. So 386 out of whatever this total is for his career. Which I don't really care about Derek Jeter, so I don't know that information. If I could encourage you to go back and look at your homework from page 469 on parametric equations, I might suggest that if you have not done this homework, and Renee, yours is still in the bucket, I haven't graded it yet, these 3 questions would be fantastic for you to look at. So if you haven't done the homework and you only have enough time to do 3 questions, maybe try those 3. And here's some old questions. Remember on our summative, I was pretty pleased with your guys' conic sections on the last one. So these are going to be optional sections for you tomorrow. So if you look back at your last summative, whoopsies, and Max and Brooklyn, I think I pinned yours on your absent work if you're back. Make sure you get that. These are going to be optional for you. So if you have anything less than a 5 and you want to retake it, you can. But just so you know, if you put down stuff that you want me to grade on these sections and you do worse, I'm giving you the worst score. So make sure if you don't want me to grade them, you put a big X through that section so I don't bother. All right, so pause the video if you want to jot these down and practice them. I'm going to stop because clearly my kid is done. with being here. Here's some more problems. And then freeze the screen, pause the video, and get those. There's a couple more good ones to practice for those optional sections. And that's it. All right. I'm very sorry for being gone. Thank you very much. Apologies. I'll see you tomorrow.